Hello, ladies and gentlemen. Welcome to 2.1 Scientific Notation, which you can find on page 36 in the purple book. Our objectives today, you'll see here first in the green, is to write very large or very small numbers in standard form and vice versa, and then to compare and order numbers in scientific notation as well. Right there. Make sure to copy all the notes that you see that are typed here or that you hear audibly in your notes as well. Okay? This, again, should be a bit of a review for some of you. If not, then welcome to scientific notation. Okay? How to write in scientific notation with a product of two factors. Okay? Your first job is to express one factor as a number greater than or equal to 1 but less than 9. So, but less than 10. So it's going to be numbers from 1 to 9. Okay? Second, express the other factor as a power of 10. Count the number of places the decimal point was moved to the left or to the right in the first factor, and use this number as the exponent of the power of 10. Okay? So if you look down here, I'm going to erase this just for a second. We've got this number right here. Let me circle it for you. Okay? 186,000. Okay? I want to get that down to a number in scientific notation where there is one number in front of a decimal multiplied by a power of 10. Okay? So we always start where the decimal place is. So I'm looking right over here. Okay? That's where we're at. Okay, let's move that decimal point. Right now, it's right here. Everybody can write that down. Okay, so we're going to go 1, 2, 3, 4, and 5. There's my new decimal point. I'm sorry, they can't really tell. I'm trying to get that in there. There's our new decimal point. So it's now going to be 1.86 times 10. We moved it over 1, 2, 3, 4, 5 spots. Okay, when you're dealing with larger numbers, your exponent will always be positive. So we moved over 5 times, so our exponent will be a positive 5. Sorry for the sloppy 5, but you know who I am. Okay? If we scroll down a little bit here, it's the same thing. It is the same thing with 23,400, which I'm going to circle right here for you in the green. Okay? So I want you to work on that one and see what you get. So pause the video, work that one out in your notebook. When you're done, hit play, and I will show you my answer. If you got the answer 2.34 times 10 to the 4th power, you'd be correct. Good job. If not, take a look and see if you counted correctly back from where the decimal point was with 23,400. Okay? Now we're going to move on to try going from the super small numbers in a scientific notation. So right here, if you look, we have 0.0000000, 7 zeros, and then a 2. So that's obviously a pretty tiny number, a much smaller number than the integer of 1. So we're going to go from that into scientific notation. So if we just draw a little arrow, okay, we're going to start where the decimal point is, which is right there. Go over 1, 2, 3, 4, 5, 6, and 7. 8. Okay, that's our new decimal. So our new decimal is 2. Oops, I'm going to rewrite that for you. 2. One more time. 2.0 times 10 to the, now remember, with larger numbers, with really large numbers, the exponents are always positive. This is a very, very small number, so we're going to always be dealing with negative exponents. Okay, because remember, negative exponents go on the bottom of fractions, which makes them a fraction of a whole number. Okay, so we went over 8 times. Again, let's count again. We'll use a different color on top. 1, 2, 3, 4, 5, 6, 7, and 8. So went over negative 8 times. Okay, so we have 2.0 times 10 to the negative 8. All right, I want you to try 0.03 4 and see what your new scientific notation number is. So pause the video, work on it, and then click play when you're ready to check. Okay, folks, if you got 3.4 times 10 to the negative second, you would be correct. Okay, we're going from a super small number to a number in between 1 and 9. Okay, so let's move on to comparing numbers in scientific notation. Okay, first we're going to compare the exponents. Oops, let's do this. So first we're going to compare the exponents, the powers of 10. Okay, the number with the greater exponent is the greater number, right? So right down here we're comparing 6.17 times 10 to the negative 6th and 3.14 times 10 to the 4th. When we compare our exponents, we have 10 to the negative 6 and 10 to the negative 4. Which one is greater? Negative 4 is greater than negative 6. So our final answer there is 3.14 times 10 to the negative 6 is greater. All right. Now, if the exponents are the same, then you're going to want to go look at the decimal factors and compare those. So right here we have 4.68 times 10 to the 9th and 3.52 times 10 to the 9th. They both have the exact same exponent, so we have to dive into the decimal factors and see which one is greater. When we compare 4.68 and 3.52, they're both positive, so we don't have to look at the absolute values or anything like that. We're just going to compare them. 4.68 is greater. So our final answer is either 3.52 times 10 to the 9th is less, or we're going to have 4.68 times 10 to the 9th is, oops, sorry about that, is greater. Okay, so now if you're looking, if you have any questions, now would be the time to either pause the video, watch it again, or stay on this last page, on this final 4th page, and we'll do a few examples, okay? So if we have 412, okay? This is obviously bigger than 9, okay? And we're going to want to put it down into scientific notation, okay? So here's our decimal place. Okay, am I gonna go to the right, make it a bigger number, or am I gonna go, oops, to the left, make it a more manageable number? What do you guys think? I totally agree with you. We're gonna go with 4.12. Again, there can only be one digit in front of the decimal. Make sure to make your decimal points very visible and clear so there's no confusion. Okay, that looks like a mess, but it's going to be a decimal point. Times 10 to the what? Well, we're dealing with a number larger than 1, so our exponent's going to be positive. It's going to be a positive 2 because we moved over 1, 2 spots. Okay? If we're dealing with a smaller number, we have 0.00123. That number is awfully tiny. Okay? Let's make it more manageable. Here's our decimal point. Let's move it over 1, 2, 3, 4. I went over 1 too many times, right? So I'm going to just back that up a little bit, back that pony up. Go right in here. That's going to equal 1.23 times 10 to the 1, 2, 3. It's going to be a negative exponent because we're dealing with a number that is smaller than 1. Okay? I want you now to complete all of the try these on this page in your textbook. Use your notes. If you need to rewatch this video, please do. Make sure to have your notes and the try these complete by the time you come to class. Okay? Good luck.